In this video, we're going to use our knowledge of x-intercepts in order to create a fairly accurate graph of a polynomial equation. So on the screen here, you'll see that we have a polynomial that's written in what looks like factored form. You'll also notice that in the instructions it says, find all of the x-intercepts. Now at this point, you should know that the x-intercepts occur when the f of x value is equal to 0. So what we're going to do here in order to find our x-intercepts points is we're going to replace all of f of x with 0. And then from here, we can utilize the zero product property to find all of the x values that make this particular equation true. Now what I notice here is that I have a couple of different segments that I can set equal to 0. I can set this part equal to 0 and find out, okay, what x values result when 1/8 x squared is equal to 0. I would divide both sides by an eighth. I'd have x squared equals 0, and I would find x equals 0. Now because this is a polynomial, I need to note how many of these types of zeros I have, and I know that I have 2 because of that squared, and as a result I know that the graph bounces on this particular x-intercept value. I can also find when this little segment equals 0 by using my zero product property. I subtract 3 from each side and I find x is equal to -3. Since there's no exponent on this one, I know that it only occurs one time and it's simply going to cross at that point. Then I look at this last segment and I can set that equal to 0. Adding 2 to each side, I find x is equal to 2 is another x-intercept. This squared here tells me that there are 2 and that the graph is going to bounce at this particular point. So just from looking at the graph and the form that it's written in, I can go straight to my graph and I can plot those x-intercepts. Now, for this particular video, we're going to go into a little more detail. After we find all of the x-intercepts, we then want to find additional points around the x-intercepts. So this time around, what we're going to do is we're going to create a table of values. And we're going to go and we're going to find, okay, well, x equals -3 is the one furthest to the left. So we're going to find what happens with y when x is -4. We're then going to look at x is -2, -1, 1, and 3. So I'm trying to hit all of the x values that are either just around or between my particular x-intercept values. So what I'm going to do here is I'm going to substitute x equals -4 into my original equation up here and find what the y value is equal to. So if we start, we'll do y equals 1/8, then I'm going to substitute x squared in there. So I have -4 squared times, that's going to be -4 plus 3, and then -4 minus 2 squared. So that becomes 1/8 times -4 squared is 16. -4 plus 3 is -1. -4 minus 2 more gives me a -6, and that's going to be squared. So that's going to be 36. Now if I multiply all of those together, I end up with a value of -72. So I can see that this graph is shooting down pretty quickly after x is -3. Then if I repeat this process with -2, so if I substitute -2 in there instead, well, the -2 squared is going to be 4. -2 plus 3 is going to be 1. Then -2 minus 2 is going to be -4. -4 squared is 16. If I multiply those together, I get 8. So I can go to x is -2, y is 8. Then repeat this process with -1. So I get -1 squared is 1. -1 plus 3 is 2. -1 minus 2 more is -3 squared, which is 9. And if I multiply all of those together, I end up with 2.25. So I can come in here and label that. Now if I repeat this process with 1, I find that my y value is going to be 0.5. And if I repeat it with 3, I get 2.25. So if I go and finish labeling all of these values, so I get, let's see, 2.25, I get a half, and then I get 2.25 over here again. I can kind of trace this through. Remember, this one was shooting really far down. It comes up, goes down. I know that it bounces off of this one because it was repeated. It bounces off of this one because it was repeated, and it shoots up. Then I can use my degree and leading coefficient to confirm that this is what was supposed to happen. Well, my leading coefficient is positive, so my right side pointing up is correct. And while my degree might not be obvious, my degree is actually all of these added together. So 2 plus 1 plus 2 equals a degree of 5. And because that is odd, I know that my ends should be pointing in opposite directions, which my graph is, so I can confirm that everything that I've done is accurate. Both of my ends are opposite, the right side is up. I found my zeros with their bounces and some accurate points between and around those points.